Hello there, and then welcome to a brand new video. This is how Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at finding the highest common factor, that is HCF, using the factor tree method. So without much ado, let's quickly look into it. So when we talk of highest common factor, what do we mean? In our earlier lessons, we looked at what factors are. And when we say the highest common factor, that is the largest number that divides any set of numbers without a remainder. You see, so you have two numbers. You can first look for all their factors. Come and look for all their common factors. Then you take the highest among the two. You get it? So let's take 12 and then 6, for instance. So for 12 and 6, the factors of 12, we have 1, 2, 3, 4, 6, and then 12. These are the factors of 12. Then for 6, we have 1, 2, 3, and then 6 itself. So among this, these are the factors, all right? So let me indicate that with an F, the factors. Then if you want the common factors, what you are going to do is you look at these two sets. Which numbers do they have in common? So we have 2 over here, and there is a 2 here as well. There is 1, and then there's 1. There is 3, and then there's 3, and then there's also 6 over here. So our set that contains their common factors is going to be 1, 2, 3, and then 6. After which, we look for their highest common factor. So highest common factor, that is going to be what? 6. So in this common factors over here, the biggest one or the highest is 6. This is how we usually solve for it. But if you have very, very big numbers, you see, you have, let's say, 1,000 and then 999, or let me say 996. For these huge numbers, it will be a little bit tedious just to list all their factors, come and look for their common factors, and then look for the highest common factor. That is where the factor tree method comes in, and that is our focus for this lesson. So to be able to determine the highest common factor using the factor tree method that leads to the method of prime factorization, then we need to consider the steps. So the steps involved are as follows. You first of all need to break each number into its prime factors using the factor tree method. And in this playlist, that is the previous video before this. Hence, if you don't know how to go through the factor tree to get out your product of prime factors, I would advise you go over that before coming to this lesson. Then secondly, you identify the common prime factors. Now, if you're able to identify the common prime factors, multiply the lowest powers of those common prime factors. Take note, the lowest, because we'll be looking at highest, the LCM, and that one will need the highest. So for highest common factor, you rather need the lowest of the common prime factors. So let's look at how we apply these steps. So in our first question here, it says we have to find the highest common factor of 36 and then 60. Now, this being the first one, I'll quickly walk you through the factor tree method. But in our subsequent ones, I would believe you have understood and you have gone through the previous lessons. Hence, you'd be able to quickly write the product of prime factors. So let's go into this one. So we need to first of all write our 36 as product of prime. And I spoke of two methods. One which you can use just your prime numbers. So I know I have a 2 times 36. 2 times and 18 gives me 36. So I write my 2 times 18 here. Then for 18, I know I have a 2 times a 9. You get it? Then for 9, I know I have a 3 times 3. Now all these numbers here are my what? Prime numbers, and there's no need to form branches. So I'll simply write my 36 to be what? A 2 times 2 times 3 times 3. And in index form, that is 2 squared times 3 squared, giving me my 36. You see, as I have said, you can just go to the previous lesson and look at how to write numbers as product of primes. So for 60 as well, my 60 is going to give me what? This one here is one method we looked at. The other one, we said you can use any set of numbers at all. So you have, let's say, 6 times 10. 6 is a composite number, and so is 10. We can form branches out of both. So for 6, I have a 2 times what? 3. And for 5, I have a 2 times 5. Now, all these set of numbers we have here are prime numbers, and we can't form any branches after them. Hence, as 60, we are going to write what? 2 times 2 times 3 times 5, which can then be written as what? 2 squared times 3 times 5. You see? So if you've been able to what? Write your numbers as what? Product of prime, what you are going to do is, you say your LCM, sorry, your HCF, which is what we are going to look for. We look at the common factors. You see, we look at the common factors. So among these common factors, there is 2 over here, then there is also 2 over here. Apart from that, there is 3, and then there is 3. You see, so we are going to write a 2 times 3. That won't end there. So we have just written the factors we see in common. But now we go to the powers. So if you take 2, for instance, there is a 2, and then there is a 2 here. Now, their powers are what? 2 and 2. So in this case, their powers are the same. If the powers are the same, you just write one of them. You get it? But if their powers are different, for instance, the next number, which is the 3, if you look at the power on this 3 here, it is 1. The power on this 2 here is 2. So what you are going to do is, you are going to take the lowest, and the lowest, I mean, you take the 1, but not the 2. You get it? So 3 to the power 1. Let me take that again. So first of all, you'd express your number as product of prime, as we have done over here. Now, if you're able to express your number as product of prime, the next step is to look out for the prime numbers that are common to both. So we have 2 here, and then there's 2 here. Fine. There's 3 here, and then there's also a 3 here. Hence, we can say that what? There's 2 and 3 that is common to both. So we come straight forward and write our 2 times 3. Then, concerning this 2 and 3, we look at those with the lowest powers. So over here, we have 2 to the power 2, and then we have 2 to the power 2. The powers are the same, so there's nothing like lowest. Hence, we just write that here. But then for 3 and then this 3 here, the power here is 1 and the power here is 2. So we prefer the lower one. You get it? So our HCF is then going to be what? 2 squared gives us a 4. That is 2 times 2. So 4 times 3 squared is what? 3 to the power 1 is 3. And 12 times 3 gives us a 12. You see? So it simply means that the highest common factor of the number 36 and then 60 is what? 12. You get it? So our highest common factor of 36 and then 60 gives us what? 12. As simple as that. You see? So that is it. Let's take one last example. And for this, I won't go over the tree method here. I'll just write out our prime factors straightforward. So in our next question here, we have to find the highest common factor of 48 and 60. Highest common factor of 48 and 60. So you can pause and then express 48 as product of prime factors and 60 also as product of prime factors. So you can pause now. Okay, so if you're able to pause and do it, that's fine. Now, you have 48 giving you 2 raised to the power 4 times 3. And I do hope you got that. For 60, on the other hand, we are going to get a 2 raised to the power 2 times 3 times 5. So if you take note, you realize that the common factors or the prime numbers that are common to both of them is what? We have 2 and then what? 2 here and then the 2 here. And then there's a 3 here and there's also a 3 here. You get that? So 2 and 3 are common to both. Hence, our highest common factor is going to be a 2 times a 3. Then now we look at their powers. So for this 2 here and this 2 here, which has the lowest power? It is certainly this one, 2. So you put that on this. Then for 3, there's 1 here and then there's 1 here. So we just take that as you see. You see? So in that case too, we are going to have another 2 to the power 2, which is 4 times 3. Wow, this is also giving us 12. So we say our highest common factor of 48 and 60 is what? A 12. As simple as you see. You get it? So simply put, if you want the highest common factor of any two set of numbers, first factor each number using the factor tree, and then you write your product of prime factors in index form. If you have them in index form, you find the common base, the common bases. You see, so in this case, we look for our common bases. And then you write their what? Their lowest powers. Then you just evaluate to get your answer. So that will be it for this lesson, and I would, as usual, leave some exercises you can use as your try work just to test your understanding. So you have these here. It says find the highest common factor of the following. So you have them here. You can try. That is 24 and 36, 18 and then 27 and then all this. Then the second one says a number is divisible by both 18 and then 30. What is the highest number that will exactly divide both? It still applies the same idea. Let's have beyond numbers where we learn maths the easy way. Now, if there's any issue of concern, you can always let me know at the comment section and then I'll address that for you. If this is your first time visiting this channel, you can always choose to subscribe. That is if you so do wish, so that anytime I release a new lesson, you can also be notified and then study with us as well. Stay safe, stay blessed. Bye for now.